In this video, I will be demonstrating the usage of the DSL3S language with Eclipse. I won't be focusing yet on the language concepts, rather on how to use the model-driven development tools to create and run models. First of all, we have to make a simple check. We go to the window menu and select Preferences and expand the Java submenu and select Compiler. Here we have to make sure that the compiler compliance level is set to something above 1.4 because that's what's required to run the models generated from DSL3S. Click OK, and we can start now by creating a new project. This will be a Java project because the end result of a DSL3S model will be a Java program. So let's call it DSL3S.example. Make sure that the default GRE is selected and click Finish. So this creates a classical Java project with the classical folder structure, and we can start by adding a folder to our DSL3S models. Right click, click New, and select Folder. So let's call this folder Models. There it is. So now that we want to start designing a model, we can shift the perspective to Papyrus, and then we get the modeling views. Now that we are in Papyrus, we can create a new Papyrus model. We go to File, New, Papyrus model. Let's call it Example again, and put it in our Models folder. Click Next. Let's say it's a UML diagram. The wizard will create a diagram, so let's call it again Example, and we can select diagram kind, UML class diagram, click Finish. So here we have our model. Now to start using the DSL3S language, we have first of all to apply the DSL3S profile to the model. So we click on the diagram, and here in the Properties view we have to select the Profile tab. And there we have a form to apply profiles. To apply the DSL3S profile, we have to use this small button here, which allows us to apply a registered profile. And here, when we click on this button, we have this menu where we have the registered profiles, where DSL3S is already included because this was registered when we installed the DSL3S plugin. So it's already selected, click OK. And here we select again DSL3S and click OK. So we can save the model now, and we can start now creating elements. So let's start with the simulation element, which is the main element in a DSL3S model. Let's call it Example Sim, and now I can start applying stereotypes. So again, with the class selected, or the UML element selected, we go to the Profile tab and use the small plus icon to apply stereotype. When I click on it, I will get a list of stereotypes in the applied profile that are available for this element. In this case, we will select Simulation and click OK. So now we have simulation here in the stereotype simulation in our stereotypes box, and if we expand it, we will see the various properties that are available for this stereotype. Unfortunately, for this version of Eclipse, there is a number of base class properties that are displayed here just ignore them. They don't do much or anything at all. So just focus on the other properties which come from the language itself. And in this case, we have the simulation name, and we can call it our example. And then in the simulation stereotype, we also have the space width and height properties. This is important especially for simulations that take place in a synthetic space, as is the case right now. And we will create a space with 50 by 50 space units. This is all abstract, but it is required because I won't be inputting any geospatial data yet to the model. Okay, so we have the base simulation already set up with this element. So now we can create a new element for an animat. Again, we add an element, a class element. Let's call it our animat, and again we apply a stereotype in the same fashion. Click on the plus button, we get the list of stereotypes, select animat, okay, and there we have the animat stereotype with all its properties. So I won't go into details for now. I will just say that I want to have 10 animats in my simulation, and that they will be wanderers. So I'll set this wanderer property to true, and this will make the animats willing to change place at each time step. So they will feel the need to move at each time step. And so the last thing I need to do now is to assign this animat to my simulation. And there it is. And save the model. And that's all. So, as you can see, this is still a pretty bare UML diagram. At this stage, with this version of Eclipse Kepler, it's not yet possible to use icons for stereotypes, so the graphical semantics is not yet as good as it can be, but hopefully the following version of Eclipse Lua will be supporting icons and will allow us to create models that are much more expressive visually. Okay, so now I have my model. Save it again. Now I can try to generate the code from this model. And this is made by going to our model and expand it to see the files that compose the Papyrus model. And here what matters to the code generator, MDD3S, it's the UML file. So to generate the Java program, we right click on the UML element, and we see that there is a submenu now called MDD3S, which has this command to generate Java code from the DSL3S model. Let's click on it. So now we have a new folder inside our project called srcgen, which contains a series of Java classes, which is basically the program that implements the model. Okay, now to run the model we have to do a final tweak. We go back to the Java perspective and we must do two things now. First of all, tell Eclipse that this is a source code folder, and secondly, add to our class path the libraries required to run a Mason program. And this is made by right-clicking on the project, going to Properties, and then select the Java build path. So first we go to the Source tab to add the new folder, the newly created folder, as a source folder. Okay, there it is. And then the libraries. We click on Add External Jars, then we have to browse for the libraries. So already at my Java folder, and these are the libraries that I downloaded in the previous video, and all I have to do is select them, and there they are. Now they are used when I try to compile or run my model. Okay, these steps, adding the libraries and adding the crcgen folder as a source folder, they are only required once. Once they are done, this information is kept by Eclipse along with the project. So now the crcgen is displayed as a source folder. It has the default package, and here we have our Java assets. So again, I won't go into details. This is basically a Mason program, and to run it we have to run the Java class that ends with the GUI. GUI means graphical user interface, and to run it is relatively simple. We right click on it and then run as Java application. Now Java will start up. So usually it takes some time. Okay, and there we have, this is the classical Mason console. So I will click on the pause button just to show you the setup. Okay, so what happened is that the new artificial or synthetic space has been created. It has 50 by 50 units, and then 10 animats have been casted randomly in this space. Now if I click to run the model or the simulation, since we have set these animats as wanderers, they would start moving, and since their movement is not set by any other assets, the movement will be completely random. So let's see it. So we have to click on the pause, and there it is. So as you see, some animats even went outside the space, our synthetic space. So this was an example to show you how to use the model-driven development tools that are used to create a model with and run a model with DSL3S language. On the following videos, I will be focusing on the language concepts and how to create more complex simulations.